Can you guys hear me? Vishal, Kiran? Vishal, Hiran, can you hear me? Guys, can you hear me? Can you hear me? Guys, can you hear me? Can you guys hear me? Akim, can you hear me? This is a post condition loop. If it is a post condition loop, it should be a repeat until, right? So repeat what? You have to print num1 because you are going to start printing from num1, right? And then what do you have to do? If you're printing the next even number, what do you have to do? You print num1 and then you are going to print the next even number. Now num1 was the starting value. What do you do? You have to add. Guys, since the time is running out, Akib, just check, right? Check your answer against what I discussed here, right? What do you have to do? If you want to print the next even number, you have to add. Now they have asked us to assume the two input numbers are even, right? So if this is an even number, the starting value, then we have to go on adding 2 by 2, no? So they have actually made it easy. If it is odd, of course, we will have to add 1 to it and then start with 2 by 2. So since this is going to be an even number, I just need to add 2 to it, right? Understand? So num1 equals num1 plus 2. Understand?
Yes.
Okay.
Yes, sir.
Now repeat. This has to be repeated until what? Now that's the condition we had to figure out. Until what? So when you're writing, remember to indent the lines like this.
Num1 is less than or equal to num2.
Okay, this is until. Until means it should reach a goal. This is not while loop, right? So until
Oh yeah,
we have to print up to
until num1 equals num2.
If num1 equals num2, then num2 will not be printed, right? I mean the upper bound will not be printed, right? The moment it equals to num2.
So then we can put we can put print num1 under.
No, it's fine. It's fine. Let's say because we do it, we do the addition first now. No, it won't because print command is above the increment. Okay.
Yeah, so we can put it under the increment.
That's right. So what we can do is no, we can't put under also. Then it will start printing from num1 plus 2, right?
So then we can put the first print outside the while loop.
Okay, then
outside the repeat loop.
Yeah, then you are repeating the print command, right? So simply what you can do is this: until num1 what? Num1 exceeds num2, right? So when num1 equals num2, fine, it gets printed. Right. So for example, here num1 is there. In this line, 2 gets added and it becomes num2. Num1 gets equal to num2. Right. So now num1 and num2 are equal, but not. This is not true. Only thing is they are equal. Okay, num1 is equal to num2 after this addition here. Let's assume, but num1 is not exceeded, hasn't exceeded num2. So it goes and print num1. So there num1 gets printed when they are equal. And here 2 will be added. What will happen? Num1 will exceed num2. And that's when it stops. Understand? Clear?
Yes.
Visual? So for example, if num1 is 5, can't be 5, no? 4, and num2 is, let's say, 6. Okay, first we print 4, then 2 is added, right? It's 6 now. Num1 is 6, num2 is also 6. 6 greater than 6 is not true. So it goes and prints 6. And then here num1 becomes 8. Num2 is 6, num1 is 8. 8 greater than 6, true, exits. Okay. Is that clear? All right, so be a little careful when you use the repeat until, right? Okay, Hiranya?
Yes, sir.
Okay, now let's move to the book. get 9. Okay, so we looked at these pseudocodes, right? And practice the pseudocode syntax, right? We write. That's very important. And you can see the for loop, right? For counter 1 to number, and do this, right? And then next counter. So this variable has to be put here as next counter, which will increment 1 by 1. Next counter. Okay, and then you can either use comma to combine a text and a value, variable value, or you can even put ampersand to join, concatenate. Right, then go through flowcharts, right? Like this, symbols, right? Maybe a flowchart can be given to be converted to pseudocode. Look at the standard way of writing the pseudocode, input, output, right? Count, increment, count, assignment, right? ASCII value, ASC, ASCII value of mycha is stored as letter value. Concatenation, old string is also a text, 97 is also a text, and we concatenate using ampersand. The operators, if statement, if my value is greater than your value, then output, indentation. End if end if. Then multiple if conditions. I mean simple if with if and else. If this is true, this will be done. Else, this will be done. And then you can also have multiple if conditions. If, else if, else, like that. And instead of using multiple if conditions, what you can do is you can use a case case statement. Now there, direction is a variable, so you can write case of direction. Right? All keywords should be in capital. Case of direction. That means you are checking the value of direction. And then you put all the values, all the possible values. If it is n, now why do you put double quotes? Because it's a text value. If it is n, increase y by 1. If it is s, increase deduct y by 1, and so on, with a colon, right? And then case, and then you have to stop it with n case. Now that's if you want to execute these conditions. But what about any other condition, any other letters other than ns, ew? Then you put otherwise. So otherwise means any of any other input. For any other input, we are going to output error. Is that clear? Case. Okay. Akib, Hiranya, Vishal?
Yes, sir.
Okay.
Yes.
Then the relational operators, equal, this is not equal, and greater than, less than, that's wrong. It should be the other way, right? Less than, this is greater than or equal to. Remember, equal comes after the greater than or less than symbol. Those are relational operators. This is less than or equal to. Right. Then the Python code, of course, they don't ask Python code. It's only the pseudocodes. And here we have iteration or loops. This is the loop using for loop for count 1 to 10. And if you want to count 2 by 2, you have to use another keyword called step. So count 1 to 10, step 2. That means it's going to start with 1 and count 2 by 2. So in the first loop, it's going to be 1. Then in the next one, it's 3. Next one, it's 5, like that. Then repeat output, please enter a positive number, input number, until. So repeat this until the number is okay. So I was telling you about the repeat until, right? So you have to repeat this as long as I mean until number is greater than 0. That means until you enter a positive number, it will keep on asking for a positive number. That's what happens here, right? Then here is the while loop. In the while loop for the same condition. In this case, it's the opposite of the previous one, right? Here you can see. Okay, now they have made it the opposite. They want you to enter a negative number, right? So number equals 0 while number is greater than or equal to 0. Output, please enter a negative number, right? That means as long as your number is a positive number or a number greater than 0, they want you to enter a negative number. It's the opposite of this scenario, right? Okay, but remember, while means as long as. Always think of while as long as. So as long as number is greater than or equal to 0. This one is a goal. What is a goal? Number has to exceed 0. So repeat all this until number exceeds 0. Understand? Is that clear? Okay. So look at only the pseudocode part, right, of the Python. Here also the same thing. Please enter the values to average input number until number is greater than 0 and number is an integer number. So int function is used to check whether number is an integer number. So until number is greater than 0 and number is an integer number, that means both conditions have to be true because of the AND operator. You ask the values to be entered again and again, right? So this is a validation process. Enter the number of values to average input number. That number is validated. Then the counter value, right? Counter for counter 1 to number. No step means it will increment 1 by 1. Okay. Right. So this is a written description. Written description. What you do is you just describe the tasks in simple English language with numbers, numbered points. Enter time taken to run marathon in hours, minutes, and seconds. Calculate and store marathon time in seconds. Output marathon time in seconds. Right? Just the steps described. That's written English. And this is what happens when you convert that into a pseudocode. It has more, standard syntax, right? And if there's a calculation, don't forget the BODMAS and the parentheses and everything correctly. Right, do some questions from here and there.
Yeah, sir.
Not difficult. It's not difficult. Look at the the flowchart symbols. Right, you can see this is a nested if. Right, so this is actually a nested if, right? Because input mark, if mark is less than 40, fail. Else if mark less than 60, pass. Else if marks less than 80, merit. So instead of writing if else if as a nested if, you can simply use a case, but that's when it comes to pseudocode. Okay. Sometimes they might give an identifier table like this. So basically what you have to do is just write the names of the variables along with a small description. That's all, right? And those are the variables that you're going to use here. Now see the nested if, and try shortening this using a case statement for practice. Okay, so here's another example. Right, try some of these questions, and you can send me the answers. I can check if you send. So you know the basic control structures, right? You have the selection, you have the iteration, and you have the sequence, and you have assignment statement as well. Assignment means you are inserting a value to a variable, you are assigning a variable value to a variable, I mean value to a variable, something like this, something like this, right? So it's not only a value that you can not only an input value that you can assign. So assign, remember the arrow goes from right to left. You can even assign a result of the calculation of a calculation to a variable. Or else you can simply assign a value, right? Or a result of a calculation. Right. Then we talked about data types. And this is how you define a data type. Declare variable name, colon, and the data type like this. Declare my birthday date. Go through them. Then we talked about record data type. And there what we do is we use type statement, end type, and then we give the name. And then we declare variables for different values, to store different values. So you can think of this as a record in a table, database table. It's like a record in a database table. In a record, you have columns. So these are like columns: title column, author column, publisher, number of pages, fiction. Right. And with one record name, you're going to store multiple values like this. So that's why it's called a record data type. So type, then the record data type name, and all the variables inside that, and end type. Now, once you define the record data type, like tbook record, you need to create an instance from this type record. It's just like each record in a table, right? This is like the design view of the table. You go to design view of table, you give the data type and the the column name and the data type. So this is like the design view of the table. This is like a record in a table. So you can create multiple records from this structure, right? So book is like just a single record, which will have title, author, publisher, number of pages, and fiction. And now the book is going to have all these columns. How are you going to access individual columns? Then you have to use the instance name, right? Declare book, tbook record. You have to use the instance name and use a dot syntax to access the columns in that record data type. Okay, so book.author equals David Watson. So it will access this author variable and assign a name called David Watson. It will access book.fiction and assign a Boolean value to fiction. Understand? Is that clear? Hiranya, Vishal, is that clear?
Yes, sir.
So try some examples. Example questions like this one. We did this in school. You can try it out. Right, then arrays. A 1D array, which has a lower bound and an upper bound. So declare a variable name, colon, array. In a single array, a 1D array, we have the lower bound and the upper bound only. And you have to mention the data type. So declare array name, array of lower bound and upper bound of data type, like this. Declare mylist array 0 to 8, if you are starting with 0, right? And of integer. And how do you access individual slots in the array? Mylist and the index number within square brackets will allow you to access individual slots. And then you can assign a value into that. Like 16 is assigned to where mylist 7 is. That's right there. Okay. Then 2D array. When it comes to 2D array, you have more data into the array definition. Same as before, declare array, my array, that's the array name of array, right? Colon array. But inside the square brackets, now you need to have 2 sets of values. The first set is for the row, second set is for the column. So this means you're going to have rows from 0 to 8, and you're going to have columns from 0 to 2. Understand? Like this. 0 to 8, you're going to have 9 rows. 0 to 2, you're going to have 3 columns. So it's a 9 by 3 grid. Okay. Now, if you want to access a particular location in the 2D array and assign a value to it, you need to give 2 values. What are the 2 values? First value is the row number. Second value is the column number. So my array 7, 0 means, where is it? 7 is the row number, 0 means the first column. It's this one. Okay, that's how you assign values in a 2D array. Okay, right. Then the linear searching algorithm. Right, in linear search, I will quickly go through it because the time is running out. So the array is given, my list array 0 to 8 of integer. Upper bound is defined, lower bound is defined. Declare index, declare item, declare found, which is Boolean. Upper bound is 8, lower bound is 0. Output, please enter item to be found, because it's a linear search. How does it work? It will start from the left corner and check each and every value to see whether it's the value that we are looking for. Input item, found false, index lower bound. Repeat. What do you repeat? If item equals my list index, right? So index is going to start from 0, right? Index is going to start from 0 because here it says index lower bound. Index equals lower bound. Lower bound is 0. So my list 0 means the first value in the list. And we are checking if our item, which we are looking for, equals to the first value in the list. If so, we set the found to true. We started with found false. Whether we found or not, we need to increase the index. Why? Because we need to go and check the other values, starting from the left corner, one by one, right? And then you have to do this whole thing until found equals true. So here, if we have found the value, it will be set to true. And here, when it comes to the condition, which is the post condition, when it becomes found equals true, it will exit the loop. So that means this will search until we find the value. Right? The moment we find the value, it will exit the loop. Understand? Or index is greater than the upper bound. That means index has incremented, and has gone out of the list boundary, upper boundary. That means we have checked the whole list. So we continue this either until we reach the end of the list, or until we find the value. At the end of the loop, we check whether the value of found is true. If the value of found is true, so they can put it like this, okay? Just if found. It is same as if found equals true. So if found, we output item found, otherwise item not found. Simple. Okay. So if they give a sorting or searching algorithm like this, they might not give the whole code to be written. I mean, whole pseudocode to be written. They might give some spaces for you to fill. So have an idea, right, of what actually happens in linear search. It checks each and every value one after the other until it is found, or until we reach the end of the list. And here's the identification table, identify table. Okay, then the bubble sort. Right, so the bubble sort, same as before, right? Variable definition, all same. Only thing is, we start from the index lower bound to top -1, right? For index equals lower bound to top -1, top is 8. Index equals lower bound is 0. That means if there are 8 values, we go from 0 to 7. Swap equals false. Right, now you know how bubble sort works, right? Bubble sort will compare values in pairs. So it takes the first pair, compare it with each other, right? If you are sorting it in ascending order, it will look at the left value. This is the left value. My list index is the left value. My list index plus 1 is the next value, or the right value, if you take a pair. So it checks whether the left value is greater than the right value. If the left value is greater than the right value, what do you have to do? You need to swap. And this is the swapping algorithm. What do you do in that? You take the left value, put it into a temp variable. You take the right value and put it into the left value. So my list index equals my list index 1. Then you take what is in temp and put it into the right value. So after finishing these 3 lines, what has happened? The 2 numbers are swapped, right? If you are doing a swap, you keep swap as true. So that's why it comes here. So if you carry out a swap, it will stay as swap true. Okay. And this swapping will happen only if the left value is greater than the right value. Why do you want to check whether left value is greater than right value? Because we are organizing the list, or we are sorting the list in ascending order. If it is ascending order, lower value should be on the left side, larger value should be on the right side. Understand? Okay, Hiranya?
Yes, sir.
Vishal? Right.
Yes.
Then what we do is, after going through from left corner to right corner, you are deducting the value of top by 1. There was a reason for that. That is because you are leaving out the rightmost value after every pass, because in bubble sort we do passes. Just by going through the list from left to right corner, it won't get sorted. You have to run through several passes. So what we do is, and you notice that after every pass, the larger values get gathered onto the right side. Like after the first pass, the largest value is on the right corner. After the second pass, the second largest is on the right corner. So you don't need to unnecessarily check all the values. So what is happening here? It is deducting the value of top one by one. That is, the list is getting lesser, smaller after every iteration. This will be continued until not SOP. That means until SOP is false. Right now, we can see that already at the beginning, the SOP is set to false. And if this condition is not true, that means if there are no SOPs, what will happen is, right, by the time you come from, you start from left to right, it will still stay as SOP false because there was no SOP. If there was a SOP, SOP will be set to true. But since there was no SOP, SOP is already set to false. And here, when it is checked, it will exit the loop, right? Or else until top is 0. That means we have checked the whole list and we have started from the top, rightmost value, and we have come down to the first value. So when the top becomes 0, you exit, or else when the SOP is false, you exit. Because there's no point, if SOP is false, there's no point continuing the pass. Okay, so just go through that, and here's the example. Go through the example illustration. Okay, then the file writing, pseudocode. Open file identifier for file mode. Open the file name for different modes. What are the different modes we have? Read, write, append. Read file identifier, variable. So this is the file name. We open the file name and put it into a variable. We put the content into a variable. Again, don't worry, because these pseudocode guides are there in the appendix. You just need to use them. That's all, right? You don't need to buy half these. Write file, you need to have the file name and the variable. Okay, this is actually called the file handle. This is the file name. This is EOF file identifier, close file identifier. Okay, take a look at this one. Declare text_ln string, my file string. You read the, you put the file name into a variable called my file, right? And then what happens? You open that file for write permission. Repeat until output, please enter line of text, input text_ln. If text_ln is not blank, is not equal to blank, then write file text_ln. Write file is the function. Text_ln is the text that user enters. Okay, you write it to the file. Else close file, my file. Right? If you're not entering any text, you can close the file. So remember, if you open a file, you definitely need to close the file. Okay, you do this, you repeat this until text_ln is blank. That means as long as you don't enter blank, or until you enter blank to text_ln, this will continue to insert whatever you type into the file. It will write whatever you type into the file. The moment you enter a blank value, it will stop. Output, the file contains these lines of text. Open my file for read. Right, now what do? You are opening the same file. My file is the same file. After writing is completed, you are opening the same file for what? For reading. Repeat, read file, text_ln. Read file is a function. Text_ln is when you read the file, you put it into a variable called text_ln. That means you read each line and then you output each line. You carry on this until you reach the end of file, of my file, right? Because you have values line by line. And then after you finish, you have to close the file. Okay, so those are two permissions. One is writing, the other one is reading. What was the other permission? Append. What's the difference between write and append? write will completely erase the existing data and write newly, whereas append will add data to the end of the file, existing data. It will add data to an existing data set at the end of the list. Understand? Is that clear? Is that clear?
Yes, sir.
Okay. Then we looked at stacks and queues, no? But not the linked list. We looked at stack and queue. So stack has a top pointer and a base pointer, and stack has a last in first out operation. That is the number or the value that is entered last will be the first to leave. So stack has two operations. One is pop, the other one is push. So here, if you pop, what will happen is what is in the top pointer will be taken out. If you push, what happens? That now after taking out the value, top pointer has to reduce by 1. Right now here you are inserting a new value which is called push. Right, when you push values, the top pointer has to be incremented first, right? Then only it will add the value to the next place. Otherwise, what will happen? It will replace 31 and add the new value, or it will replace 82 and add 31. So remember, when you're pushing values, top pointer has to be incremented first before inserting the new value. Okay, so here's the operation for declaring the stack. Go through it, right? And here's the operation for push operation for stack. And here is the operation for pop in a stack. Right. Queue. When it comes to queue, you have the front pointer and you have the rear pointer, right? And queue has a functionality of first in, first out, right? So this is the item which was added first, 27, and after dequeue means you are removing values from the queue. What has happened? 27 has gone. So the value that was in the front has gone, and the front pointer has been taken down. I mean, has been incremented by 1. Okay, so if you are inserting a value, that is called enqueue. If you are removing a value, it's called dequeue. If you are enqueuing, you enqueue to the rear pointer, to the place. I mean, rear pointer has to be incremented by 1, and then you have to enqueue. So remember, you are enqueuing to the rear side. You are performing dequeue on the front side, right? Okay, so just look at that, and then how to set up a queue, and how to perform enqueue. In the exam, I don't think they will ask you to write the pseudocode completely, right? They might give some spaces and then ask you to fill, right? If they ask you to write fully, it will be a small part, not the whole code. I mean, I'm talking about ADT, right? But there can be programs given to solve and ask you to write the pseudocode completely, right? Different scenarios. This is removing an item from a queue, which is called dequeue. So something to keep in mind is if you are enqueuing, you have to check whether the queue is full. Before you insert a value, you have to check whether the queue is full. When you are dequeuing, you have to check whether the queue is empty. Right? How can I remove values if there are no values? Okay, so linked list, of course, we didn't do. Okay, then we jump to chapter 12. Yeah, in chapter 12, we didn't do system development lifecycle, but we jumped to what is known as structure charts. So go through structure charts. Right. So structure chart is another graphical representation of a problem, a model, right? And you look at the standard way of drawing it. You have the variables passing and coming out into these modules. So this is what is known as the decomposition. We have broken down the major problem into 3 separate small problems, and these are going to be developed as modules. Okay, so for modules, we send data items, and modules will return data items to you as well, to the main program as well. That's what this picture shows you, right? Okay. And this is how you put a condition to a structure chart. Like here, you are converting between Fahrenheit and Celsius. You can put a question and ask whether they want temperature in Fahrenheit. If they say yes, look at how it is put, right? So look at the standard way. If it is yes, you go to this module, which is to convert into Celsius. If it is false, you go to the other module. So this is how you show the selection. And here's the repetition, right? You might have these steps to be run over and over again. And if you are using a repetition, it has to be done until you satisfy a condition. Otherwise, it will keep on running without stopping. So first thing is you need to draw an arc like this, cutting the lines that are going to be repeated. So in this particular example, all these 3 lines will be repeated. That's why it's cut. It cuts up all 3. And you are going to continue this until a certain condition is met. So that condition has to be placed next to the main box. So this will be repeated until temperature is 9999. Understand? Is that clear? Is that clear?
Yes.
So when the temperature, Hiranya, is that clear?
Yes,
Hiranya? So this will be continued until you enter 999 for temperature. When you enter 999 for temperature, it will exit the loop. Okay, here's an example where the loop and the selection are both in one. So in this case, you'll be looping this until the radius is 0. If the radius is 0, you stop. So what does it do? It calculates the volume and the surface area of volume and the surface area of what? Sphere. And there you need to ask a question like, do you want to calculate the sphere's volume, or do you want to calculate the sphere's surface area? So that's why we have a diamond like that. Okay, finally, what you should know is this. Now you can see, and I told you like these boxes will be represented as modules when you actually write the program. And here they have introduced writing pseudocode for the modules above. Provide pseudocode for the module shown in the structure diagram as calculate volume and calculate surface area. Provide the answer to the calculation. And these can be defined as functions. Right? That means these boxes can be defined as either programs or subprograms or functions. Okay, so most of you know the difference between function and procedure. Procedure does not return any values, but function will always return a value. So what they have done here is calculate volume. That is this one. Calculate volume. Now you can see these parameters. One parameter is coming into the module and the other one is going out of the module. That means when you call the calculate volume